So we'll start off there at the next one. And you can see here that this one's wrote slightly differently. You're used to doing long division when it's asking you to just divide two terms. Sometimes they write it as a fraction because you know when they write it as a fraction, it's the exact same thing as saying divides, how many times does 3x plus 1 divide into 6x squared minus 10x minus 4. So we'll just lay that out in so it looks like long division. Okay, so 3x plus 1. Okay, so we want to know how many times that divides in. So we'll start by doing as we always do, and we start by doing divide. So first we're going to see is how many times 3x divides into 6x squared. So 3x divides into 6x squared, and the answer there is going to be 2x. And we can verify that by saying that 3x multiplied by 2x, 3 times 2 gives you 6, and x times x gives you x squared. Okay, so that brings us on to the multiply section. So, like we just said there, 3x times 2x will give us 6x squared. So we'll type that in. But now we need to do plus 1. So plus 1 times 2x will give us plus 2x. So we've done everything we can do there. We can't multiply anything else. So now we need to look at the subtract. So what we'll do is we will subtract the terms. So we're going to draw our line and change our signs because we're subtracting. And we can see there that 2x squares will cancel because 6x squared minus 6x squared leave you with nothing. And then that brings us to the second term. So if we look at this, we have negative 10x subtract 2x. So again, think of it like money in the bank. If you owe the bank 10 euro and you subtract 2 euro, or you withdraw a further 2 euro, you then owe the bank 12 euro. So we've got negative 12x. We're just going to bring down this negative 4 here because we haven't divided that in. We haven't divided into that yet. So we're just going to bring that down because that's still part of the sum. And now we're going to start the next cycle. So this is the first cycle complete. And now we're going to do the same thing again for the second cycle. So we're starting all over again. And let's just look here. So if we look at it, when we look at it now, I'm just going to bring this down. And it looks almost as if this here doesn't exist. So we're going to pretend that that doesn't exist. And our new sum that we're looking at now is we're looking at how many times 3x plus 1 divides into negative 12x minus 4. Okay, so everything that we've done is now complete. We're moving on to the next cycle, and that's to see how many times 3x plus 1 divides into negative 12x minus 4. Okay, now I'll bring that away again just so you can see. So we're going to divide again. So 3x divides into minus 12x minus 4 times. So we're going to put in our minus 4. Our next step is to multiply. So what we need to multiply now is we need to multiply the 3x by the minus 4 and the plus 1 by the minus 4. So we'll do that now and we'll multiply that in. So 3x by minus 4 gives us minus 12x. Plus 1 by minus 4 gives us minus 4. And that brings us to the last step, which is to subtract. So what we're going to do there is we're going to draw our line and we're going to change our signs. So draw your line, change your signs. And the reason again why I'm saying change your signs is because you're subtracting a negative. So what we're doing here is we're subtracting a negative 12. So if we have a minus minus, it turns into a plus. And similarly, we're subtracting a negative 4. So if we subtract, we'll have a minus minus, and that turns into a plus. And you can see there that these are going to cancel. So from that, we can see that 3x plus 1 is a factor. So 3x plus 1 is a factor of this because it divides in evenly. But also 2x minus 4 is a factor of this because it divides in evenly. And another way of looking at that is that 3x plus 1 multiplied by 2x minus 4 should give you 6x squared minus 10x minus 4. Okay. Okay, so what we're going to look at next is this one here. This is the exact same thing. This is just getting you to understand that long division isn't always written as a fraction, or it isn't always written as a function divided by another function, you could say, right? So it's important that you understand how these can be written. So it says, show that x minus 1 is a factor of x cubed minus 3x squared minus 13x plus 15. So cubic functions, typically you don't really deal with cubic functions all that much for junior cert, but for leaving cert they do come up. So we'll just go into that now. So we'll just lay this out. So we're showing that this here is a factor of this. So if you think about it, if you were to list the factors of 20, so if we were to pick the number 20, and if we were going to get the factors of 20, we would say 1 times 20, 2 times 10, 4 times 5, and so on. So you can see there are factors or numbers that divide into the number 20 evenly. Okay, so factors are numbers that divide in evenly. So I want to be able to show that this divides in evenly to this. Okay, so that's our whole goal there. So how we do that is we just lay this out. It's a cubic function, so we'll just write out a cubic function. X cubed minus 3x squared minus 13x plus 15, all divided by x minus 1. Now, this looks more challenging, but it's not. The only difference is this one here is a cubic function, so it just means I need to do this cycle 3 times. Here I have to do it twice, but for a cubic function I have to do it 3 times. So it's the exact same thing, it's just going to be a longer sum. So we'll start off there by doing the first step in this. The first step, as we know, is divide. Okay, so I need to see how many times x divides into x cubed. At this stage I should know that x divides into x cubed x squared times. Okay, now that's the division part of the sum done. So now I'm going to move on and do the multiplication. So the multiplication is where I take this and I multiply it by x squared and fill it in down here. So the first part is going to be x times x squared, and I know that's going to give me x cubed. I now need to multiply, I've done the x, so I now need to multiply the negative 1. So negative 1 times x squared will give me negative 1x squared. I can't multiply anymore, so now I need to move on to the next step, which is subtraction. So in order to subtract, I need to draw my line straight across and change my signs. So I'm subtracting, so this positive here will turn into a negative, and similarly this negative here will turn into a positive. Now we saw that in the last question, and the reason why this is the case is because I'm subtracting a negative. So if you have a negative, it turns into a positive. We'll just tidy all this up, and we see there that our x cubes are going to cancel. And we also see that if we have negative 3 and we add 1 to it, we'll end up with negative 2. And that's obviously x squares. So negative 2x squared. So you can see here what we've achieved so far is that we've seen how many times this divides into this. It's important to remember though that we're not just looking to see how many times it divides into this. We're looking to see how many times this divides into the entire cubic function. So we need to bring these terms down, and we're going to do the same thing again. So I'll just bring these terms down now. And that will be minus 13x, and this plus 15 will come down. And you can see there that we still need to divide this into this. to get our final answer up here. So to help see what's happening here, I'm going to just bring this down here. And effectively you can see that what I'm actually dealing with now is I'm looking at this and I'm more or less starting a brand new cycle, and I'm starting the whole thing over again. So I'm basically seeing how many times this divides into whatever was left of this, and whatever's left there is in white. Okay, so I'm starting a brand new cycle and I'm just seeing how many times x minus 1 divides into this, because this was left over from my initial long division. So I can move that back up out of the way, and I'll start my second cycle. So the second cycle is to see how many times this divides into this. So we'll start by doing the second cycle. So we can see there x divides into minus 2x squared, and it's going to be minus 2x times. So I'll put in my minus 2x. Okay, we can double check that by saying x times minus 2x gives you minus 2x squared. So that brings us on to the next part, which is multiplication. And as we just did there, x times minus 2x will give you minus 2x squared. So I'm going to put in the minus 2x squared. That's the first term multiplied by the minus 2x. I also need to multiply the second term. So negative 1 times minus 2x, and negative by a negative will give us a positive. And 1 by 2x will give us 2x. That's our second step finished. So we're now going to move on to the third step, and we know the third step is subtraction. So I'm going to draw a line across there. And what I'm going to do next is I'm going to subtract negative 2, and I'm going to subtract positive 2. So if I'm going to subtract, effectively what I'm going to do is I'm going to change the signs. So this is going to change from a negative to a positive, because it's a minus minus, and a minus minus turns into a positive. And this is going to turn into a negative, because I'm subtracting a positive, which is the same as having a negative. So these here will cancel, because minus 2 and plus 2, minus 2x squared and plus 2x squared will cancel. And then I can look at my numbers. So minus 13x minus 2x is the same as saying if you owe the bank €13 and you take out another €2, you then owe the bank 15. So that would be minus 15x. And I'm going to bring down my last term there, which is plus 15. So that's our second cycle complete, and you can see that here. And that brings me back onto this. I'm just going to bring this back down here again. Now, if I can get that to come up there. And what I want to show you now is just that what we're doing this time around is similar to what we did the last time. We're starting all over again, and we're going to see how many times this divides into what was left over. Okay? So we'll start that again. I'll just move this up out of the way so you can see it's all part of the same sum. And we'll start that off by seeing how many times we can divide x into minus 15x. So x into minus 15x. So we know that will go in minus 15 times, because minus 15 times x, or x times minus 15, gives us minus 15x. So that's our first step done. Next we have the division, or the multiplication I should say. So the multiplication, and we're going to multiply this by negative 15. So we'll do it term by term. So x times negative 15 gives us negative 15x. And then negative 1 times negative 15. Again, here we have to be extra careful with signs, because a negative by a negative will give us a positive. So we put in a positive, and again, 1 by 15 is 15. The last step there is to subtract. So we're going to draw our line and change our signs. So a negative will turn into a positive, and a positive will turn into a negative. The easy way to remember that is you draw your line and change your sign. So if it was negative, it goes positive. If it was positive, it goes negative. And the reasoning behind that, again, just in case anyone's still not sure, it's because we're subtracting a minus 15. So if we subtract a minus, it turns into a positive, because a negative negative turns into a positive. And here, obviously, we had 15 and we're subtracting 15. So it's going to be a negative 15. And again, we can see that that's going to, these two here are going to cancel, and we'll be left with 0. Okay, so just to clarify, so everyone's clear, we started off, we want to show that x minus 1 is a factor. So x minus 1 is a factor of this cubic function. And we did that because we showed that x minus 1 divides into this cubic function. And if it divides in evenly to this cubic function, then it has to be a factor. And we can see here that it divides in evenly because we don't have any remainders. This here multiplied by this gives us this. And the other way of looking at that is that this here, x minus 1 and x squared minus 2x minus 15 are both factors of this. Okay.